Hey everybody, it's Mr. Dan, and today I'm going to just walk you through some of the problems that I gave you in the video lesson the other day from this homework assignment. Okay, so before we get started, just read these questions here. These are similar to questions that I showed you way back in the stoichiometry days. So where are you now? Where are you going? What will you need and how will you get there? These are questions that will be important to answer as you try to work through word problems like we're going to do here. Let's look at the first one. If a 30 milliliter container is at 2.5 atmospheres of pressure, how would the pressure change if the volume were changed to 20 milliliters? First question is, where are you now? So what you need to do is read the question and then pull out the quantitative information that it has in there. What are the numbers? And assign variables to them. We can see that we have volume and pressure here listed. And if you read through the question, it tells you what the final thing is that you're supposed to find. What's your unknown? Where are you going? So that pressure change, that's the new pressure, that's where you want to go. So what are you going to need to get there? Looking at the variables, we have volume and pressure. Gas laws that relate volume and pressure is Boyle's law. Boyle's law looks like this. Pressure and volume have an inverse function, meaning that as one goes up, the other goes down. Maybe you can predict what will happen to the final pressure based off of the changes. Before we can go on, we have to assign 1s and 2s to our variables on the left in blue. By reading the question, we can see that we have starting numbers of 30 milliliters and 2.5 atmospheres. That's going to be P1 and V1. The question, or where are we going in this case, is what it will change into. If we change the volume to 20 milliliters, what will be the new pressure? Those are both the results. Okay, now we can start putting our numbers into the equation. You can do this in two ways. You can either just sort of do a plug and chug where you put the numbers in, or you can rearrange the starting equation so that your unknown variable is isolated. That's what I like to do, and that's the way that I'll show you here. So we need to isolate for P2. So you can see that by dividing both sides by V2, we can cancel it out on the right side and then transfer it over to the left side. Now we still have all four variables, but our unknown is isolated, meaning it's all alone. So now when we put in the numbers, we can do a quick calculation in our calculator. So our volumes will cancel in this case. And we'll be left with the units of atmospheres, which is what pressure is. Do the calculations, and what you'll find is that the pressure is 0.375 atmospheres. So here we figured out where we were starting at and where we needed to go. Boyle's law is the tool that we needed, and in order to get there, we had to put the numbers into the equation and solve for the unknown. Most of these problems will work the exact same way. Oops. Okay, next one. Where are you now? If a 50 milliliter balloon at 350 Kelvin is compressed to 10 milliliters, what is the new temperature? Where are you now? What information do you have? That's it for what we're given in the problem. What's the question asking us? Or where are we going? What is the new temperature? That's our unknown. So, when relating volume and temperature, we're using Charles' law. This is a direct relationship, meaning that as the volume increases, the temperature also increases, as long as the other variables like pressure or the amount of gas remain constant. We have to read the question again to figure out which one's V1 and V2 and which one's T1 and T2. Based off of reading it, we know that there's a new temperature that will result from a change. That's going to be T2. And there's a volume associated with that. If the gas is compressed to 10 milliliters, what's the new temperature? So 10 milliliters goes along with T2. You can also then from there figure out that the V1 and T1 are those top two numbers. Now we're ready to put the numbers into our problem. You can either just put them in, or you can isolate for the variable. I like to recommend putting isolating for the variable before you put the numbers in. So here we need to isolate for T2, meaning we have to get T2 into the numerator and all by itself. By multiplying both sides by T2, we can eliminate that variable from the denominator, and then we can move it up into the numerator onto the other side. Now we just have to get V1 and T1 away from there. So multiply by the reciprocal, and they'll both cancel out. Make sure to do it on both sides. On the left side, the variables will cancel out. T1 over T1 is equal to 1. V1 over V1 is equal to 1. We don't have to write those down, so we can cancel them out. Now we're left with our new equation. All the variables are still there. They've just been reorganized so that T2 is all by itself. Now we can put the numbers into our equation and solve. The volumes will cancel out, and we'll be left with a temperature in Kelvin, which is our unit that we're looking for. As we solve this in our calculator, we'll get to an answer where T2 is equal to 70 Kelvin. One more problem. If a gas-filled container at 75 degrees Celsius and 130 kilopascals is heated to a temperature of 100 degrees Celsius, what is the new pressure? Where are you now is the first question. So let's write the information we know. And where are we going? Or what is the question? What is the new pressure? That's the thing we don't know. So how are we going to find this new pressure? What will you need? Gas law, the gas law that relates temperature and pressure is Gay-Lussac's law. It says P1 over T1 equals P2 over T2. This is also a direct relationship where as pressure increases, so will temperature. Or if temperature decreases, so will pressure, as long as the other variables remain constant. So the volume and the amount of gas must remain constant for this relationship to work. Let's isolate for our variable before we try to solve. So we need to get, which one is it? We haven't figured out which one is T1 or T2 or P1 or P2. So we've got to read the question and figure it out. The new pressure is what's going to result from heating it up. We're going to start at a lower temperature and then we're going to heat it. So low temperature to high, 75 to 100. So 75 is going to be 1, 100 is going to be 2. It's going to start at 130 kilopascals and then it's going to end somewhere we don't know yet. So 130 kilopascals will be our starting pressure, and our unknown is our final one. Now we can isolate for P2. This one worked out a lot shorter than the previous one. Only one move and we can get P2 all by itself. Now before we can put our numbers into the equation, we have to make a change. There's an important rule about pressure and about gas laws, that we have to always follow. And that is that temperature must always be in Kelvin. So how do we get there? This is also a really easy step to take. To convert from Celsius to Kelvin, all you've got to do is add 273 to your Celsius temperature. And if you want to go back to Celsius, just take Kelvin and subtract 273. Given that, our new temperatures will be like this. Now we're ready to put it into the equation. Notice how I didn't have to change the pressure from kilopascals into atmospheres. You can use whatever pressure system you want as long as you're consistent throughout the problem. So if you're starting with atmospheres, end with atmospheres. If you're starting with kilopascals or millimeters of mercury or torr or anything else, just make sure you use that from beginning to end. All right. Our temperatures have canceled out, and our final unit is left in pressure or kilopascals, so we're ready to solve this thing. So there we have it. 139.3 kilopascals is our final answer here. Notice how I gave the units for all the answers on every question. Please make sure that whenever you're answering these, you always give the correct units. Okay, guys. So I hope this was helpful for you. Please remember these steps up here, right? Start with these questions and just work your way through them. And I think you'll find you'll find yourself wherever it is that you need to go. If you have any more questions, you can send me an email. You can send me a message through Google Chats, Hangouts. You can comment to this on Google Classroom. Let me know if you have questions. I'd be happy to work out a way to help you understand these better. All right? Good luck, guys. Thanks.